In examples 1 through 3, we took the same approach. In each problem, we just identified A, B, and C, substituted those into the quadratic formula, and got our answers. In the next two examples, we're going to have to introduce just a little bit more work, because keep in mind, for the quadratic formula to work, we need a quadratic equation of the form ax squared plus bx plus c is equal to 0. That means the equation that we're given in example 4 won't work with the quadratic equation, or the quadratic formula, the way that it's written. What we need to do is manipulate the terms, modify the equation to get it into this standard form that we want. To do that, what we'll do is first subtract 6x from both sides, which will give us x squared minus 6x is still equal to the negative 5 we have over on the right-hand side. So for our last step, we'll add 5 to both sides, which will give us x squared minus 6x plus 5 is equal to 0. Now that we have this written in the correct form, we could identify our values for A, which would be 1, B would be negative 6, and C, I should use lowercase just to be consistent here. Our value for A would be 1, B would be negative 6, and C would be positive 5. We need to make sure the first thing we do is get the equation in this standard form before we apply the quadratic formula. In example 5, we want to look at 4 additional cases where we have to make some modifications to the equation that we're given in order to apply the quadratic formula. In part A, we have a similar example that we had in example 4. What we need to do is subtract 11x to the other side, add 11x, and then subtract 15, which will leave us with 0 on the right-hand side. In part B, we don't need to move any terms to one side or the other, but what we do need to do is account for the fact that there's no constant term. There's no value for c, the way this expression is written. What we need to do then is introduce that constant term. We don't necessarily have to literally write this out, but at least do this in our head, that there's a plus 0 term implied in this equation. So in this case, our value for c that we would plug into the quadratic equation, quadratic formula, would be a value of 0. In part C, we're missing, again, a term, and we have a value on the wrong side of the equation. So that term that we're missing is the x term, so we'll plug in a plus 0x, which is really just a placeholder to let us know that our value for b would be 0. And then we'll subtract 64 over to the left-hand side of the equation, giving us a quadratic formula set equal to 0. In part D, we have something that looks quite a bit different. Here what we'll need to do is expand everything out on the left-hand side. So we'll FOIL, meaning we'll take 4x times 4x to get 16x squared. We'll multiply the outside terms, which would give us negative 4x. Multiply the inside terms, which would give us minus 4x. And multiply the two last terms, which would be positive 1. So keep in mind what we're really doing there is taking 4x minus 1 times 4x minus 1 and FOILing that out, expanding that out. Simplifying, this would give us 16x squared minus 8x plus 1. And then we'll need to subtract 9 to the left-hand side to get 0 by itself on the right-hand side of that equation. And then we'll just combine like terms one more time to get 16x squared minus 8x minus 8 is equal to 0. In each of these cases then, again, what we've done is just modify the equation to get it in that standard form. Ax squared plus bx plus c is equal to 0. And in cases where we had missing terms, we dropped in a placeholder as just a representation to let us know the value of that letter would be 0 in the formula.